Before we take on tonight's homework, we gotta talk about and review real fast what you should have already been looking at in your notes. What it means to rationalize. We started off class yesterday by talking about common denominators. In fractions, what is the purpose of multiplying by 1 creatively? Not to get rid of anything.
Set it equal.
To get a
Common
common denominator. So you guys have said it a few times now. Good. To get a common denominator. We multiply by 1 creatively to get a common denominator to legally be able to combine. To legally be able to combine. So over here in this one, same thing. What's the purpose of a common denominator? What's the purpose of the common denominator? Sorry, of multiplying by 1 creatively. To get a common denominator to be able to combine. Now, in this one, in this section, we're not trying to combine fractions. We're just trying to simplify fractions. And as we saw yesterday, the way to simplify a fraction with a radical in the denominator, whether it shows up as a whole fraction underneath or whether it shows up just as a radical in the denominator alone, both of these are not simplified until we get the radical out. Let's go ahead and put all writing utensils down that you can hear your mouse. And what noises you did be quiet, okay? Let's put all writing utensils down. Okay. So, before we continue on class, that'll be very real fast. For some reason, we have a lot of attitudes today. I'm not exactly sure why I don't know, for some reason we're thinking class rules don't apply to us anymore. So let's pretty quick just for the kids, for your patience, and for you guys, so hopefully be open to learning today while following class rules. Follow our preaching for today, praise for the kids before us, that they will just cover this class period with grace and that they may be able to obey and to attention and to learn in the midst of whatever distractions and whatever else is going on. Do the same. Alright, here we go. He's given us grace and we can persevere despite all the different things. So, I want you to think real quickly about yourself. Hopefully you have some sort of motivation you want to do well in this class because it is super important, as I talked about multiple times before. And not only your teacher in the math department, Sharon, I'm saying you gotta have this class. Okay? You gotta learn algebra. Okay? So think about yourselves and then think about the people around you. And if you care about them, I'm not going to go into how we're supposed to love others as Christ has loved us, but if we care about anyone around us in any way, shape, or form, we should want their success as well as our own. And the way that some of you guys treat each other, the way that some of you guys make noises and cannot show discipline, show restraint, show focus, you're hurting the other people around you as well, and that's sad. Because you might be out of here with a good grade, but then if they can't, you're forcing them to take a whole other class again. Diego, go ahead and go out in the hallway for a while until you... Why is your head down? Okay. You can go ahead and stay as long as your head stays up. So then yesterday we were talking about, let's go ahead and try to refocus once again, thinking about not only ourselves, but hopefully the others around us even better than ourselves, because they deserve our respect, they deserve our care, and they deserve our attention, and our lack of distraction. So, we have these things called radicals, and they're not allowed to be in the denominator. We can't stay that way. We have these things called fractions under a radical, and they can't stay that way either. We have ways of trying to simplify, but as we talked about yesterday, the 2 doesn't break down, the 3 doesn't break down, the 2 doesn't break down, the x doesn't break down. There has to be another way, and it's called rationalize. You guys say it, rationalize. Rationalize. How do we rationalize? That wasn't it. Say it better, rationalize.
Rationalize.
There we go. We got all the different consonants and syllables and vowels in there. To rationalize, we got to multiply top and bottom. Josh, please. Thank you. In order to rationalize, we need to multiply top and bottom by... If the radical is alone, by whatever's down there messing it up. If it's alone, it's easy. Multiply top and bottom by what's exactly there. So in your warm-up, was the radical alone?
Yes.
3.
The first 2. The radical was alone.
That was 4.
So we need to multiply by 1 creatively on both of these. And we say, where is the problem? This guy right here. Okay, the smart board's being funky. This guy right here is our problem. What are we going to multiply by? Same top and bottom to rationalize. Tyler and Rob, stay in your own personal space. What are we going to multiply by? Square root of 3. Has to be the same top and bottom. If you didn't do this in your warm-up, do it now and correct it because you got stuck. If you did do it, check it with us.
I forget it.
Okay? Kaylee, question on this.
For my final answer, is it just the number or does it?
Let's see what happens.
I can't think of
That's a
the
good
bottom,
question. Some people weren't quite sure how to keep going. We're not done yet. Yesterday we talked about if one's under the radical and one's not, can we combine them and make 12?
Take it out. No.
3's in the house, 4's locked outside. We're done. That's it.
Oh, what?
3's in the house, 4's
Is
locked
it
outside.
over? Is it from my final answer?
On the numerator. In the numerator. Thank you, Tara.
Oh, okay.
Okay, we're just multiplying straight across. 4 is locked out, 3's in the house, we're just leaving it that way.
What would you get about?
And the denominator, let's talk about that.
Just right
Can we put the 3 times 3 together since they both are in the house?
Yes.
Yeah. So we'd end up getting square root of 9. The square root remains, because we have to think square root of 3 times 3, or square root of 9.
Okay.
But we can keep going, because that's not simplified yet. Diego, go ahead. How do we keep going?
You're going to 3 in the numerator.
Because the square root of 9 is 3. Good. And then what stays up in the numerator?
That's all. You can go into the.
Now, just a few of you. Just a few of you. Pause, pause, pause. Just a few of you might think that maybe you can cancel out these 3's. Even if you were able to get all the way here and cancel out. That one's outside, he's locked outside, he's in the house. We're done. We're done. Box it, we're done. For those of you guys that are a little bit stuck, we're going to have some extra examples at the end of class. But, pause, there are multiple ones, so let me explain one more time.
Oh, because that's the square.
This step is what is new. We're learning how to rationalize when there are radicals in the denominator, square roots in the denominator.
So now what is the.
We multiply same top and bottom, and with fractions, we multiply across.
But there's more than one.
Ah, we're getting there. Hold on. So then, when we multiply across, the 4 stays out, and the radical 3 stays the same, because these can't join. One's out, one's in. We're stuck. They stay. And the bottom, if I have square root of 3 times square root of 3, if you want to see how I got to square root of 9, I did the square root of 3 times 3. Since they're both under square roots, I'm allowed to combine. The product property of radicals say if I multiply a radical times a radical, I can put it together, and that's how I got root 9. And who is squared in 9? 3 is squared. The square root of 9 is 3. Katie, go ahead.
So, when you multiply the square root of 3 times square root of 3, what if, like, would it be okay if on the denominator it would be the square root of 3 squared?
Yeah, that's totally fine as well. So then, Ian, give me one more second, Diego. Kaylee said another way of writing it is you could do the square root of 3 squared, because there's a pair of 3's, at which case we can cross out the square root, and that's how the 3 stays. Or the 3 is the final answer. So we saw earlier, square root asks, are there any pairs of 2? And we say yes. And they say, okay, what's the pair of 2 of? 3. That's the answer. Square root. Square root is the answer of whatever is being squared. Okay. And letter B, we're going to go on to that one, but I want you guys, while I answer Jordan's question, just to think about, is the radical alone? Now, there might be more stuff underneath him, but is he alone? Yes or no? Is there a plus or minus? No. The radical is alone. So, you're going to follow the same step of steal the denominator, multiply top and bottom by that denominator. Go ahead and start, because some of you might have gotten stuck. Jordan, go ahead.
Is it always going to work out the way it did in A, the example we had yesterday, where like it's going to be 3? And
Whenever it's a square root, we just need a pair, so if we multiply it by one other one, it'll always go. If it's a cubed root and there's only one, we might need to multiply it by something squared so that there are now 3.
so like, the 3 would work as 3 times 3 is 9. And then like for
If it was 4, it'd be 4.
4,
Yeah, so whatever this is, when I multiply it by itself, I have a pair now. I have a square.
There's only 5.
And this is a cubed root, then I'm going to need 3. So if I only have 1, I might need to multiply it.
square roots actually work, so it's always going to be like, even if it was like a million, it's still be over.
Because it'd be a million.
Okay.
The square root of 2.
So we're always gonna multiply
When it's alone, when the radical is alone. So, Josh, when the radical was alone, we got to follow the same trick. What did you fill in those blanks? What did you put there?
I didn't get that one.
Okay, that's all right. Caleb, did you figure out what do you think we should put?
I mean, I tried. I took an attempt.
Yeah. What you put?
Well, I mean, I just put like the reciprocals for like 2 times 2 times 2 to equal 6 on the top, and then like I know the m because like
Oh, so you're kind of rewriting it first, huh?
yeah, and then I put the m reciprocal for m, and then another one for m squared reciprocal, and then 3, and so I just got like reciprocal 2 on the top, and then like 3 and on the bottom.
So then Caleb was trying to break these things down. Now the sad thing about 3n cubed is he was saying the 3 just kind of stays,
I thought it was
but the n does break down,
okay, yeah.
right? So then if we have a square root, he's trying to simplify first, which is a good technique. It might make it a little more complicated, but he was like, wait a minute, this isn't even simplified in themselves first. So we're going to come back to that, and we're going to see maybe we're going to have to simplify at the very end. So I might come back to that, Caleb.
Okay.
But just for the sake of seeing that square root in the denominator and saying you're not allowed to stay there, and I cannot square root 3, we're going to use the rationalizing trick of using that denominator, because he's the problem. Do you guys want me to spotlight the problem? Spotlight the problem. And that's what we write down on top of each other. What was the problem up in the first one? Spotlight the problem. He's who I wrote down.
Even if there's more than one number, you still use the same thing.
As long as there's only one radical, even if there are multiple
So if there was like a 4.
pieces being multiplied underneath it, you still just use it once. So Rob, let me write it real quick. Let me write it real quick. See? There was only one radical in the denominator. He's my problem. The denominator is my problem. I spotlight him and I write it on top and bottom. Still have a question?
May I please use the motion? Like, I just have to go. It'll be like 2 minutes.
Zoom zoom. Alright kiddos, now that we have this multiplication, we actually have to simplify. So let's think. You have to ask yourself, are they both in the house, are they both outside, or is one out, one in? They're both in the house because they're both underneath, right? Okay. Are we allowed to put them together? The answer is
Yes.
So it would be 6.
So it would be 8 times 3.
So is it 24? 24 and third over 2.
Let's get there. Let's get there. Guys, what happens if I square a square root? We could do this multiple ways, but can I show you the shortcut one?
Use like this one.
Ready?
This is so much better. Can we keep doing math like this?
This is how we have been doing
I would know. I spent like days on like one lesson.
Why wouldn't it be 9
We spend at least 2 days on every
I
single lesson. Yeah, we do.
I thought
Part
we
1,
had-
part 2.
I think spent like one day and then go on
Sometimes
the
we
next.
spend it.
Ms. D, why wouldn't it be
Oh,
9?
that's
Why was
8-6.
Because like,
8-6 was the one.
imagine if you
Can I
did
just
that.
Come back, guys, I'm losing you. We're losing time, and this is what happens. And this is why we can't keep doing math like this. Focus.
Rats.
Here we go. Pause. Alright, we're staying 2 minutes after. Just gonna go multiples of 2 now. Come on, we gotta get stuff done. I said 3n cubed times 3n cubed is 3n cubed squared. Because it's multiplied by itself. I'm showing that because what's gonna happen, like with this, the squared and the square root cancel, what can I do here? I can cancel. And why is that nice? What is no longer in the denominator? But what's in the numerator now?
Radical of 24 and 2.
Okay. Now, as Caleb said earlier, as he was trying to say, those numbers in the beginning weren't simplified yet. Which means I'm not done, because 24 is not simplified either. So we're going to have to look at that answer and say, are there any pairs we can simplify down? Jordan, what do you think?
Is the answer gonna be the square root of 8?
No, you're close.
Because the 3 so the m cubed cancels out for both top and bottom, right? Right. But then 3
No, n cubed, because one's under the house and one's not. So we can't just combine. Yeah. 24, isn't that, does anybody see a perfect square in 24?
No.
Tyler and Rob, I see those hands. You can put them down. I'll get back to you.
I didn't get that.
4 times 6 is a good way, right? N cubed, are there any pairs in N cubed?
Yes.
N times N times N. Why is that nice? Well, I can rewrite this problem to be square root of 4 times square root of N squared. Does that make sense? I'm taking the pair. But what else do I have besides that?
And
All over it. 3n cubed is already outside of the radical, so he's okay. Diego, I'm teaching now, it's time to be quiet. So what can I do with square root of 4? 2. Is there anything else that I can simplify? I simplified this one.
The N squared.
Yeah, the n squared I can simplify, right? So I can cross off the squared and the square root. Diego, what did I just ask you a second ago? I said I am teaching. Please be quiet. It's time to be quiet. Okay? Obey, please. Coming back. The square root of n squared is just n alone. So I'm going to write that n alone. Question, guys. What's stuck under the square root?
6 and N.
So then they're both going to be in the house. There we go.
And over.
So close to being done. Tyler, remember I said you can put your hand down? I see that. I'll get
It's
back
not
to you
up.
guys. Oh, going back. It's okay. He can rest his hand where he wants it.
Wait, what happened?
I split up 24 using 4 and 6. I split up 24 using 4 and 6. I split up n cubed. And I saw that there's a perfect square here. This is 2 squared, so 2 is remaining. N squared, n is remaining. Square root of 6, guys, if I break that down, that's 2 times 3. I got nothing. Yeah, but not a perfect square root. So I'm going to leave it this way to keep it precise. And then square root of n, same thing. It's not n squared. It remains. Now, I'm so close to being done. There's one very, very, very tiny simplification we can make. Does anybody see anything shared top and bottom?
and
Right here. Now, I can't touch that one. Why? You tell me.
So
Yeah.
2 square root
Plus.
of 6 and
Squared.
3 and squared.
But I can simplify, exactly, I can simplify this 1n with this n cubed. And how many, can you guys tell? How many are left down here?
3.
Yeah. So there's going to be 2 n's remaining. If it helps, you could always, write out n cubed and say, isn't that n times n times n? And how many reduce away? Just 1. And what's left over? It took us a while to get there, but guys, we finally did.
Did you
3.
take out a,
I've been writing the N squared on the whole.
did you take out a 1?
Oh my gosh, that's crazy.
Not
So it
really.
would be square root of 6
Like,
over
I messed up on the 6.
Well, we can't
The top part.
think if we're factoring, we're dividing, we're not
On
subtracting.
the bottom.
So 3 is 3 times 1, and there's 3 times 1, can't simplify the 2.
Okay, so 6 and 3.
Alright kiddos, that one's boxed. We have one more problem. I know that one was kind of long, you guys hung in there, but first let me answer while you guys are looking at problem C, seeing what's different. Rob, what was your question?
I'm so confused. Why when you did 3n to the third and you multiplied, why didn't you do 9n?
That doesn't fit. I thought that was it.
I'm so confused.
3n,
What?
where?
What is it? Why would
It
you
would,
how?
it would
Okay.
be 9 and would be
Yeah,
easier
yeah,
like
let me
that.
explain. Let me explain. We could have multiplied and got 9 and n to the power of 6. Because it'd be n cubed and another n cubed, so it'd be n to the 6th.
You can do n to the third, 9 and 1 to the third.
No, because we have an n cubed and another n cubed. So we have n, that'd be n to the power of 6 altogether. So we could have written 9n to the 6th.
So we rather just cancel out of it.
But the reason why I like showing the squared is because it shows you, the whole reason we did that was to cancel out the radical. Does that make sense? And that's the same thing I did up here. Remember how I wrote 9 the first time? And then I said it's 3 squared so we can cancel out the square root. I was just trying to show you the same thing down there. Tyler.
Okay, so for the square, why'd you cross out nothing on the square? Like
Oh, I crossed out the squared and I crossed out the radical.
Oh.
Does that make sense?
Yeah.
And the inside stays untouched, just like the 3 stayed untouched up there.
I don't understand.
Okay? Good questions. Did you get both of your guys'?
Yeah.
Bob, I got yours too?
I got high school every day. That's something I do.
So guys, letter C.
Because I don't understand.
The radical's not alone.
I'm confused.
On what then?
Everything.
Pause.
Can you just do it?
We're doing example C.
I feel you.
I know, can we finish?
I feel you. I'm not going to re-explain both of these examples, but I am going to just point out one more time. On A and B, these radicals are alone. In C, do you see how the radical is not alone? There's like a whole other piece.
Yeah.
It's a binomial, 2 terms.
You just add it.
Pause. Coming back here. When the radicals are alone, spotlight that denominator and say, hey, I'm going to multiply top and bottom. That's what rationalizing is called from yesterday's notes. So the process is see what's alone, multiply top and bottom, and the rest is simplifying radicals. Okay? What did we do here? We saw the denominator, we spotlighted it, and we said, hey, multiply top and bottom. That's what rationalizing is. Multiplying top and bottom, the rest is simplifying. Okay? So maybe you got stuck a little bit in here, it got kind of long and complicated. But the long story short, we saw a radical alone, we spotlighted, we multiplied top and bottom. To rationalize, we just got to keep going, and eventually, did we end up with something where there is no radical anymore? In the denominator, yes, that was the goal. We can come back and look at it, Josh, maybe during lunch, or period 7 if you can come in and miss a little bit of baseball. Are you in baseball? Yeah. All right, hold on. Radical is alone. In the first 2. Let's finish C.
Oh my God.
All right, 2 more minutes, guys. I don't know what to do.
Oh my god.
Focus. I said 2 more, so now we're up to 12. All right, they don't want 2 more. The radical is not alone. So here's what I need you guys to do. When you would spotlight 2 pieces, okay? When you would spotlight 2 pieces, we need to multiply yesterday what we called the conjugate. We need to multiply by the conjugate. I'm going to go ahead and like kind of section this part off because he was already kind of done for the top example, okay? There we go. Whenever we have a radical not alone, it doesn't have to be 2 radicals. It could be 3 plus root 3. It doesn't have to be 2 radicals. But whenever we have 2 pieces, not just one, we have to go ahead and multiply by what we call the conjugate. And yesterday we said the conjugate are the exact same 2 pieces except.
Except
Do you remember what changed?
the sign changes.
The sign changes. Instead of a plus, we put a minus.
Why?
Because that's all.
It's okay. It's okay. What changes whenever we have those 2 terms, whenever the radicals are not alone, we write the exact same thing except we have to change the middle sign. We're going to come right back
Let's go negative.
to our notes because this is why you guys need to look at your notes.
I do.
Yesterday we wrote whenever the radical is not alone, we rationalize multiplying by the conjugate. What is there? We use the opposite sign. So, the example, the one that we did yesterday was kind of long, and I passed that rule test. Do you see how the radical wasn't just by himself? There's more. I multiplied almost by him, the exact same, except what changed?
Negative.
Yeah,
So I think
that's why it's called the conjugate. That's why it's called the conjugate. Tyler and Caleb, after what was said, or who initiated, we just didn't quite down. So if I give a test or a quiz right now, I'm pretty sure the majority of us are failing. So I'm trying to help. But if you don't need help, this is when I say open up a book, teach yourselves. I'll check in on you tomorrow, and we'll have a test soon. That's not what you want. That's not what I want. So you have to respect me enough to say she's trying to help. And if I only pay attention, maybe I can learn. Kaylee, go ahead. Kaylee.
So if it was minus, we have to change it up.
Exactly, it'd be a plus, it'd be the opposite sign. Okay, is that your same question, Josh?
No, I was just gonna say, I don't know why, but I'm like about to fall asleep. Can I try and like splash water in my face?
No, but you can go ahead and stand up like some of the people, I know Dylan that kept him awake the other day, and it works. So you can go ahead and stand, Josh, I don't mind.
Alright,
I don't mind. I'm just gonna have you stand up and back, that way you're not like in
Can you
front.
screw up just a little bit?
I will, but can you guys put parentheses around?
Can I ask a question?
Okay, just like we did above, it's time for us to multiply. It's time for us to multiply. So, if we're going to multiply the top, kiddos, how do we multiply one thing outside of parentheses? What do you remember?
Whoa.
Called starts with a D and ends with a tribute.
Distribute.
There we go. So we're going to distribute this to both. And you guys see how everybody's in the house? Okay. So then, root 3 times root 7. What do you guys think that first one's going to be? 21. But underneath the square root, right? Root 3 times root 3. That's going to be, they're going across a minus, root 9. Okay, and the denominator. How do we...
It's like a distributive problem.
Exactly. Distribute.
That's it.
That's okay. Shh, 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 shh. No judgment. Coming back. And the bottom, do you guys see how, I'm going to start with first, because aren't I going to have to do first, outer, inner, last?
Yeah.
Now, does your brain work better with square root of 49? Oh, it's going to be 7. Or square root of 7 squared. Oh, that's going to be 7.
7 squared because this.
Okay, some are 49, but I hear some others being 7 squared. So let's go ahead and try the 7 squared. So square root of 7 times square root of 7 is square root of 7 squared. Then I have, we did first, what's it time to do now? What's it time to do now?
21.
Okay, because we have a minus in front, good enough. And then, yeah, it's going to be 21. So we did outer. Nothing squared, so I can't write that. Inner. Positive though, right? A positive times a positive is going to be root 21.
Oh, then you would cancel them out.
Yeah, close, Rob, but we don't want to get sidetracked or else sometimes we forget things, so let's go ahead and finish. First, outer, inner,
Oh.
last. We got to do FOIL.
Why is it?
We got to FOIL first. Hold on, we're foiling, okay? So first, outer, inner, last. A positive root 3 times a negative root 3 is a negative root 3 squared, right? Some of you guys think 9, and that's good as well. Now we're trying to simplify, so we're going down. Let me zoom in on this problem. What's it about? Is there anything that we can reduce? Rob, cancel what out? The negative 21 and the positive 21. Sounds good. On the top, square root of 21 is stuck. We don't know him, right? But do we know the square root of 9 or 3 squared?
You lost this.
It's 3. Do we know the square root of 7 squared?
Yeah, 7.
We can cancel out the radical with the squared and we can have 7. Minus, do we know radical 3 squared? Cancel out the radical with the squared, we get 3. If these are too close together for some of you, let me spread them apart. It's a big old fraction that we're trying to simplify. So we went from here to here after distributing and foiling. Then we're trying to simplify to here. And we're so stinking close. All we have to do is say, well, 7 minus 3, those are both out of the house. What do we got? 4. And technically the right way to write this one would be minus is adding a negative. We would usually write the negative 3 first and the radical at the very end.
Let's just say you only like rationalize when the.
Oh, I got 4 at the beginning of the problem.
We have to rationalize when we can't break down what's under the square root to get rid of it, and when there are radicals in the denominator.
I want to use adding.
Because they're not like, ooh, great question. This was actually what we were supposed to be doing today in simplifying radicals. Now hold on, Angel asked a really good question. We may still have 4 minutes after the bell anyway. I know, I wish we didn't either. It is what it is.
Oh.
Here it is. How would we, when would we be allowed to add radicals? When would we, how would we be able to add radicals?
I need notes.
What did I say up here?
Combine.
Oh wait, there are no x's or y's. I don't understand. How are we combining? look at the radicals and say, are there any radicals that are the same? And Angel, here's the dealio. You can only put together like radicals.
So like,
So we can put 3 root 2 and 10 root 2 to make, does anybody know?
you add the numbers outside too.
It's like terms. So think apples and oranges. If I have 3 apples and 10 apples, it'd be how many apples? 13. But I'm not adding apples, I'm adding root 2s.
Oh, but you wouldn't add. You keep it two.
And then I took care of this one, and I took care of that one, but what didn't I take care of?
Minus root 6.
So here's the dealio. You have to ask yourself, can I break down 6,
No,
2, and 3? No, no squares. No pairs.
that's right.
So then you say, are they alike?
No.
Apples and oranges, we gotta keep them separate. Okay?
What happens if what if you put it in a factory when you're on?
We could put over 1, but you don't need to. Now guys, we still have 3 minutes, and that's how to do adding, and you could do something similar with subtracting. You combine like terms. What's the other?
Wait, can you do that?
Get on Sunday. I do.
It's okay, we still have 2 more minutes after this one goes around to the clock. If you guys want to start writing, the other one is how do we do operations with multiplication? How do we multiply radicals? Okay, so this is how do we add or subtract. We're only allowed to put them together when they're alike. So, Alan, pretend as though it's 3 times x and 10 times x, and this is a y. I'm only allowed to combine if they are alike.
Oh, yeah.
So, 3 root 2s and 10 root 2s make 13 root
I just
2s.
add them.
Yeah,
Okay.
but only if they are alike.
Okay.
He's not odd man out.
It's just 3 plus 10.
3 plus 10 is 13.
That makes sense.
Okay?
And
So-
wait,
Oh, go ahead.
I wonder since it's like root 2, like why isn't it like root 2 squared or something like that?
You would think it was, technically, Caleb, or for the rest of you guys that are wondering why this is true. Addition is commutative. We could actually write it this way. I could rearrange how this is written. And if you guys look at just these 2, if I was to group these, is there anything in common? Is anything shared? You could pull out the root 2 and you would get 3 plus 10. So then we would have 13 root 2 minus 6 under the root. Same thing. Now I love that you guys are packing up. You technically still have 1 more minute. I said 4, and we had 1 more example to do. So we're still doing it, and we're going until we finish it. How do we multiply? How do we multiply? Josh, what do you think?
Distribute.
Good. So I have something on the outside. I'm going to bring it in. Question. What is the 3 supposed to multiply by if he's under the house? The 8 or the 2?
Inside.
Just the 2.
So
then 8
over
root
6
6
plus 7.
plus, now we got to distribute.
Holy cow. That's a big number.
That's not. It's
7
That's 100.
root, Justin's helped us out, 96. Now pause. Pause. I don't want to add time, but we said we had to finish, guys.
Oh, yeah, sure.
We're stuck. They're not alike unless we need to break down to 96. Does anyone know something that goes into 96?
32.
Do you want me to help?
16.
4 and 24.
Hi, Mr. Charles.
We can keep on breaking down. Guys, if you distract and you guys can't focus, we have to finish this problem. We have another 4 and another 6, right? We could keep going, but can I help out just a little bit to help us finish?
Why is there
Down.
4 under the 4?
Oh, do you guys do your circle thing? That's right, I forgot. Is that better?
No.
4 and 24. 24 becomes 4 and 6. All of these are 96. We have 4 squared times 6. Okay. What can we do with our product property? Break them apart, right?
Yeah.
How does that help?
Wait, for 96, can't you simplify 1?
I could, but see, Tyler, I saw that 4 times 4 was a perfect square. I saw that it was a pair, and I'm like, oh, sweet, I'll capitalize on that. Because can't I simplify it? Square root of 16 or square root of 4 squared? What does that become?
4 square.
Just 4, right? Square root of 16 is 4. Square root of 4 squared is just 4. So I have 8 root 6. Is 4 out of the house now? Did you kids left?
Yeah.
So I have 7 times 4 times root 6, which is just 20. Oh my goodness, do you guys see how they became like terms?
Yeah.
So I have 8 and I have 28. I can combine them now.
36.
8 and 28. I can make it 36. They had like terms I was allowed to combine.
Hey.
Kiddos, look and listen. I know it'd be so easy for you guys to be like, oh, she's awful and she just makes everything take forever, but pause. Can you guys explain to me why we stayed 5 extra minutes? It was supposed to be 4, 1 extra minute. She got distracted in the 4. Why did we have to stay? There was noise. Other people get distracted by noise and talking. Any other reasons?
Don't pay attention.
Goofing off, not paying attention? You need to focus. You guys did a good job in the last few minutes. Get out of here. Except, wait, pause. Did you take a picture of homework? I learned that you guys don't take pictures and don't look online if you don't have it. 48 and 49. Do tomorrow.
Bye. Please.
I'll take
Bye.
48,
Please
49,
go. Bye. Look, keep